Bismillahirrahmanirrahim. So in this problem, random vector x bar has the PDF given below. Fx of x bar is equal to c multiplied by e raised to the power minus b dash bar x bar, while x is greater than or equal to 0 and this is 0 otherwise, where b bar is equal to 1, 3, 5 transpose, and find the following. Part A, the constant c. Part B, the Cdf of x bar Fx of x. So here in this problem we are given a random vector, and while in print and in books this random vector x is usually denoted using a bold face letter. Here with the handwriting we usually use a bar over this x to denote that this is a random vector x. This is not a single random variable, this is a random vector instead. So likewise this dash here or this accent here is used to denote that this vector b is a transpose, right? So let's begin with the solution to this problem. So we're given that b is a vector which is equal to 1, 3, 5 and the transpose of this row vector here. So transpose of this row must be a column like this. So b bar is in fact this column vector with 3 elements, 1, 3 and 5. But here in this function we use b dash bar instead. So b dash bar will be a transpose of this, right? So this will again come out to be that row vector. So b dash bar is a row vector with 3 elements. We are only told that x is a random vector here, right? But the number of elements of x are not given. So we can deduce this from this product here. Vector x is multiplied by this vector b dash bar. So b dash bar has 3 elements. So, and this is a row vector here, right? So x must also have 3 elements, and for them to be conformable, b dash bar and x bar, for them to be conformable, this must be a column vector, right? So let us suppose that x is equal to, with these 3, this column vector with these 3 elements, x1, x2 and x3. So this is a row vector and this must be a column vector. This has 3 elements, so this must also have 3 elements for them to be conformable for multiplication like given here. So let's now evaluate this expression b dash bar x bar. So that will be equal to the product of this row vector here 1, 3, 5 multiplied by x1, x2 and x3. So 1 multiplied by x1 plus 3 multiplied by x2 plus 5 multiplied by x3. So this is b dash bar x bar, right? So we can put this expression here and we can rewrite this PDF in this form also. C e raised to power minus, and for this we write this here, minus x1 plus 3x2 plus 5x3, right? While x1 is greater than or equal to 0, x2 is greater than or equal to 0, x3 is greater than or equal to 0, and this is 0 otherwise, right? So now let's find out the constant c, part A of our problem. The constant c, right? So this PDF evaluated over the entire region must evaluate to 1. So in other words, this integral from minus infinity to plus infinity, when we integrate this PDF, the answer should come out to be equal to 1. So we can use this function here, this form of the PDF here, to evaluate this integral. So as this has 3 elements, this must be a triple integral, right? So minus infinity to plus infinity, minus infinity to plus infinity, minus infinity to plus infinity, and c e raised to power minus x1 plus 3x2 plus 5x3, and with respect to dx1, dx2, dx3, and the answer should come out to be equal to 1, right? So note that we are given that x bar is greater than or equal to 0, so that's why x1 is x2 and x3 are all greater than 0. So the lower limit here will be 0 here, right? So we can write this integral, triple integral, like this: 0 to plus infinity, 0 to plus infinity, 0 to plus infinity, and c can be taken outside as a constant, e raised to power actually we can write this like this also: e raised to power minus x1 multiplied by e raised to power minus 3x2 multiplied by e raised to power minus 5x3, and dx1, dx2, dx3, and the answer should be 1 here, right? So strictly speaking, we must integrate first with respect to x1, then with respect to x2, and last of all with respect to x3. But if we look carefully, all of these terms are functions of individual variables. So we can split the integration into 3 parts. So for example, we can split the integrals like this: c 0 to plus infinity e raised to power minus x1 dx1, right, and multiplied by 0 to plus infinity e raised to power minus 3x2 dx2, and multiplied by 0 to plus infinity e raised to power minus 5x3 dx3, and this should be evaluate to 1. So we can now find out the individual integrals. So this is a c here, constant, and the integral for e raised to power minus x1 will come out to be minus 1 multiplied by e raised to power minus x1, and we take the limits 0 to infinity, right? And similarly for e raised to power minus 3x2, so we will have a constant minus 1 over 3 multiplied by e raised to power minus 3x2, and the limits will be 0 to infinity. And similarly we will have minus 1 over 5 multiplied by e raised to power minus 5x3 with limits of x3 from 0 to plus infinity. The answer should be equal to 1. The product of all these terms should be equal to 1. So let us now substitute the values for the limits here. So this is c into minus 1. So this is e raised to power minus x1 is basically e raised to the 1 over e raised to the power x1. So this is 1 over e raised to the power infinity, right? And minus e raised to the power 0, right? So next, minus 1 over 3, and let's put the limits here. So this is 1 over e raised to the power 3x2, and when we put this value of x2 is equal to infinity here, so this will be 1 over e raised to the power 3 infinity, 3 times infinity, 3 times infinity is again infinity. So this will be 1 over e raised to the power infinity minus e raised to the power 3 multiplied by 0, so that will be 0 again, e raised to the power 0, right? And minus 1 over 5, and when we put the limits here now again, so this will be 1 over e raised to the power infinity minus e raised to the power 0 here, and the answer should all come out to be equal to 1. So 1 over e raised power infinity is 0 and e raised power 0 is 1. Here again this is 0 and this is minus 1. 0 minus 1. So the computation should be straightforward. So c into minus 1, and next we have 0 and minus 1, right? So this will be 0 minus 1, and then minus 1 over 3, minus 1 over 3, then 0 minus 1, and then minus 1 over 5 and 0 minus 1, and the answer should all be equal to 1, right? So this can be simplified as c into minus 1. This is again 0 minus 1 is minus 1, minus 1 over 3. This is 0 minus 1 is minus 1. This is minus 1 over 5, and this is minus 1, and this is equal to 1. So this is basically c multiplied by 1 over 3 into 1 over 5. This should be 1 over 15. And we can determine the sign here. Minus 1 multiplied by minus 1 is positive. Minus 1 over 3 multiplied by minus 1 is again positive. Minus 1 over 5 multiplied by minus 1 is positive. The sign is positive, right? So this is equal to 1. So in other words, this means that c is equal to 15. So the value of the constant is 15. So we can rewrite our PDF here like this. Fx of x is given by 15 e raised power minus b dash bar x bar, and x bar is greater than or equal to 0, and this is 0 otherwise, right? Where b dash bar is already given, the value of b are given, where b dash bar is 1, 3, 5. So this is our PDF, right? With this constant now. So the next part of our problem is to find the Cdf of x, fx of x, right? So the Cdf of x can be found by integrating the PDF here, right? So if we integrate the PDF, we will get the CDF. So fx of x is given by this integral here from minus infinity to x, right? So if we are using x in the limit, we must use dummy variable here. For example, instead of writing fx of x, we write fy of y, and we integrate with respect to y. Y is the dummy variable here. So as we know that our PDF has 3 elements. The vector has 3 elements. So we can again use the triple integral here. So fx of x is given by this triple integral here. 15 and e raised to the power minus, we have x1 3x2 plus 3x2 plus 5x3, and we will be integrating with respect to x1, x2 and x3, and the limits will be here from minus infinity to x1, x2 and x3. So as we are using x1, x2 and x3 in the limit, we must use dummy variables here instead of x1, x2 and x3 here. So let us say instead of x1 we use u, right? For x2 we use v, so this will be 3v plus 5w, and this will be du, dv, dw, right? So we are using dummy variables, for x1 we are using u, right, and for x2 we are using v, and for x3 we are using w. These are the dummy variables, because ultimately the answer would will use x1, x2 and x3 for the CDF. So like we did earlier, this integral, triple integral, could be split up because these are individual functions of individual variables. So the lower limit will be 0 because x1, x2 or x3 are greater than or equal to 0. So this will be 0 to x1 here, 0 to x2 here, and 0 to x3 here. This is the limit for u, this is for v, and this is for w, right? And we have 15, and this could be split up e raised to power minus u multiplied by e raised to power minus 3v multiplied by e raised to power minus 5w, and du, dv, and dw here, right? So 15 is a constant, it can be written outside, and as these terms are functions of individual variables, these three integrals could be split. So we can, for example, write here u is equal to 0 to x1 e raised to power minus u du here multiplied by v is equal to 0 to x2 e raised to power minus 3v dv multiplied by w is equal to 0 to x3 e raised to power minus 5w and dw here, right? So let's evaluate the integrals. So 15 here, and this will be minus 1 multiplied by e raised to power minus u, and u is from 0 to x1, right? And this will be minus 1 over 3, and minus 1 over 3 multiplied by e raised to the power minus 3v, and the limits will be from 0 to x2, and again this will be minus 1 over 5 while e raised to power minus 5w, and this is 0 to x3 here. So let's substitute the limits now. So this is 15 minus 1, and this will be e raised to the power, let's substitute x1 for u now. So e raised to power minus x1 and minus e raised to power 0, right? And this will be minus 1 over 3, and this will be e raised to power minus 3 x2 minus e raised to power 0, and here minus 1 over 5 into e raised to power minus 5x3 minus e raised to power 0, right? So we can next write it like this. So this is 15. We can take this negative we can multiply this whole expression within this parenthesis with minus 1. So this will be e raised to power minus e raised to power minus x1 plus e raised to power 0. The e raised to power 0 is basically 1. So this could be written as 1 minus e raised to power minus x1. So likewise, we can take this negative 1 inside here, right? So this will be 1 minus e raised to power minus 3x2, and here also this will be 1 over 5, and this will be 1 minus e raised to power minus 5x3 here, right? So this is 1 over 3 and 1 over 5. This should be 1 over 15. This will cancel out with this, right? So we are left with this expression. So this will be 1 minus e raised power minus x1 and 1 minus e raised power minus 3x2 and multiplied by 1 minus e raised power minus 5x3, right? So basically the Cdf Fx of x is given by this expression, 1 minus e raised power minus x1 multiplied by 1 minus e raised power minus 3x2 here, and multiplied by 1 minus e raised power minus 5x3, right? And x1 is greater than or equal to 0, x2 is greater than or equal to 0, x3 is greater than or equal to 0, right? And this is 0 otherwise, right? So this is the complete expression for the CDF. So this completes our solution here for this problem.